Quartz is the raw material for making chips. First, it is crushed, ground, and placed in a high-temperature furnace for purification. It is then refined into monocrystalline silicon with a purity of 99.99%. Next, the silicon is cut into 300 mm diameter wafers. Each wafer is 0.75 mm thick. A barcode is sprayed on the back for production. A small notch is made for equipment to recognize its direction. Silicon wafers are very fragile. They can easily break when bumped. The cost of a single wafer is about $100. However, once made into a CPU, its value can reach $100,000. It becomes more valuable than gold. Wafers coming off the production line are not always perfect. Each chip undergoes rigorous testing. Defective chips usually have only performance differences. Testing programs mark the defective areas. The chips are then classified based on their yield. Intel uses this method to classify its i9, i7, i5, and i3 processors. As the price decreases, the number of defects in the processors increases. This is the CPU of a desktop computer. When we talk about chips, we mean the integrated circuit inside. It has 24 computing cores, a memory controller, and a GPU chip. When you zoom in on the core, you see different functional partitions. Zooming in on one partition, we can see the layout of 44,000 transistors. These transistors account for only 0.0017% of the total number. Zooming in the chip 100,000 times, you see a dense network of metal wiring layers. Below the wires are transistors for basic logic operations. Transistors are covered with insulators and metal lines. The combined length of these lines is hundreds of kilometers. Each transistor layer has 5 metal wiring layers. They are interconnected by metal vias. A CPU chip is stacked layer by layer. In this way, the material for making chips is a 300 mm silicon wafer. This silicon wafer can produce 230 CPU chips. In contrast, memory chips are much smaller. A single silicon wafer can produce over 900 memory chips. Before production, 25 silicon wafers are stacked together. They are placed in a box with sensors. These boxes are transported along tracks to various equipment. The system sends the boxes to the appropriate equipment based on specific steps. Each machine has a special robotic arm. It places the wafers on the workbench for processing according to the system's instructions. After unloading, the box continues along the track to the next piece of equipment. The entire manufacturing process involves thousands of such boxes. Coating the silicon wafer with photoresist is the first step in chip manufacturing. After applying the photoresist, it is placed on a baking plate. The plate heats up to evaporate impurities from the photoresist. The wafer is then placed on the lithography machine. The top of the machine has UV light and a patterned mask. Light passes through the mask pattern. It is focused by lenses and projected onto the silicon wafer. The wafer is then placed in a developer solution. The solution removes the photoresist exposed to UV light. What remains is the circuit pattern from the mask. The circuit pattern is etched on the lithography machine. The lithography machine is the most important tool in chip manufacturing. It has a UV light source lens at the bottom. Above are lenses for focusing the light. At the top is a mask plate containing the circuit pattern. It acts like a film negative. At the bottom is the track and holder for the silicon wafer. Light times before reaching mask. It is then refracted more times, focusing the pattern to 1/4 size and projecting it onto the photoresist. This process includes 2 crucial steps: lithography and etching. The mask plate is a 6-inch square which fits 2 CPU circuit diagrams. The lithography machine copies and pastes the diagram onto the wafer in a few minutes. It can write billions of transistors 230 times. Each chip layer's circuit diagram is different. An 80-layer CPU chip needs 80 different mask plates. Each mask plate costs $300,000. To improve production efficiency, chip manufacturing uses at least 400 devices simultaneously. This allows for the production of 50,000 wafers or over 10 million chips per month. Even with this, demand still exceeds supply.